Good afternoon. Welcome to the Esri Policy Forum. Thank you very much for your participation. My name is Shuichi Matsuda, Vice President of the Economic and Social Research Institute, Esri, Cabinet Office, Japanese government. And so let's start. Today's topic is re-engineering official statistics through big data and AI. We have a very, very good speaker, Professor Shapiro, and we have a good, great discussant, Professor Ueno. So let's straight go to the presentation. Please, about 40 to 45 minutes.
Okay. Thank you very much for the kind introduction. I'm delighted to be here, and I was delighted to have the invitation to talk some about this project. I have a couple of aims today. First, I want to talk about challenges facing the statistical system. Start with an example, and then go on to say what's features of the system which were optimized for the 20th century, both economy and information technology, are now, if not out of date, getting out of date. So the question is, how can we lever both the information created by the economy in the information age, but also the technology, and therefore the machine learning, artificial intelligence, both to study the economy, but I think, frankly, it's very important that the statistical agencies figure out how to lever this new technology. And I will be talking about a specific application, which is quite important. And then I'm going to talk some about a new project. It's was just funded, but where we hope to actually implement this in a way that will actually have some effects on how economic statistics are conducted in the U.S. and I hope around the world. So this is part of the RESET project, which stands for Re-engineering Economic Statistics Using Transactions Data. I want to acknowledge it's a joint project of the University of Maryland, the University of Michigan, and the Census Bureau. My co-principal investigators are John Haltwanger at the University of Maryland and Ron Jarman, who is currently the acting director of the U.S. Census Bureau. And then I'm also going to talk about commercial partners, which are very important for implementing this new reality. So let me start with a parable. Why you might want to do this? Why we might have wished to have these kind of data almost 20 years ago. So cast your minds back to January 2009. This is actually when I first met Josh Hausman, who is sitting in the audience, who was brought to the CEA by Christina Romer, and the Obama administration was facing the problem of what to do about the economy. The economy was apparently in free fall, and it was quite serious about designing a stimulus package that would address what looked like possibly a coming Great Recession. So one question was how bad was the economy, and then a second question was how big should the stimulus package be? And again, cast your mind back to February 2009, January 2009, as the administration was coming in. So the Obama administration, it was pretty clear things were pretty bad and wanted a major stimulus package. Strange as it may seem, given the political realities now, there was a lot of consideration and concern in the Congress at that time about the budget deficit and the size of additional borrowing. You might remember that in the fall of 2008, the TARP program was held up by the Congress. They had to try twice to pass it, and that was over concerns about the deficit. And then with the change in administration in particular, there was a lot of Republican skepticism about whether a big stimulus package was actually needed. The economy measured by employment was falling off a cliff. Those last four bars are the negative change in payroll employment of about half a million workers per month in the final 4 months of 2008. So the labor market looked really bad. And it was sort of obvious to the administration that something needed to be done. That is not what GDP showed. This is a chart of what the Congress and the administration were looking at in 2000 in February 2009. The data was as of January 2009. This is just real GDP. It's normalized to equal 1 on the left side of in 2007 fourth quarter, which was when the NBR declared a peak. Actually, GDP continued to grow through the first half of 2008. Why is that? You might remember there was a late Bush administration stimulus package, one of the first tax rebates. And then there was a downturn, but not a sharp downturn in the fourth quarter, started by the Lehman crisis. But the GDP was barely below the level it was at the peak at this time, and this made it hard for the incoming Obama administration to argue for a significant stimulus package. This is what the data would look like if you downloaded them now from Fred. Exactly the same time series, but there have been revisions. And there was a particularly big revision in the fourth quarter. And now, unlike back in 2009, the GDP data looks like it was falling off the cliff in a similar way that the unemployment statistics are. And I believe had the Obama administration been armed with a picture like this, it might have argued for a bigger stimulus package and perhaps a longer live one. So this can really matter. Now I've cherry picked this. This is one of the biggest economics events, and for reasons which I'll tell you, the data do particularly bad at turning points. But of course, that's when we need the data, when we have to make big decisions, and we have some like that coming up now. So why do you get a picture like this? And then I hope I'll tell you how we might fix it. So there are very long lags in data availability of the underlying data for GDP. Now, of course, the data come out 4 weeks after the end of the quarter, but they're based on very preliminary underlying source data. The fundamental benchmark for the economy, and I'll talk about this at the end if I have time, is collected only once every five years. Is the only time when we do an economic census of all establishments, and that's where we get the very detailed establishment level product detail. The high frequency data, what basically drives month to month and quarter to quarter movements in GDP, is largely a census survey of retail sales, and that's done at the firm level. Basically, Target, Walmart report what their aggregate sales are. So you get a pretty good read on what's going on overall, but not a very good read on the composition. Moreover, for the income side, which is largely based off of tax filings, of course, we don't even file our taxes until the end of after the end of the year, and it takes the IRS a couple of years to get the data over to the Census Bureau. So that's a source of lags. In the meantime, they do extrapolation, interpolation, and that chart I showed you is a salient result of that. Moreover, the status quo more generally in the U.S. has a surprising system, and it's partially because it was developed almost over a century ago, starting in the BLS started collecting price statistics in 1913, and we have a system where different agencies, actually housed in different cabinet departments, collect different pieces of the GDP statistics. So the Census Bureau, which is housed in the Department of Commerce, collects the numerator of GDP, basically revenue or sales. The Bureau of Labor Statistics, which is housed in the Labor Department, collects prices. Those are the same prices that are used to do the CPI are also used to deflate the personal consumption component of GDP. And then the BEA, a third agency, does the long division. It takes the nominal P times Q from the Census Bureau and divides it by price, and that gets you real GDP. So that's kind of a pastiche of our statistical system, but not far from the truth. And this creates all sorts of problems, including the ones I alluded to, but also other ones we want to address, largely related to inflation and productivity measurement. So these different agencies collect prices and quantities, or prices and revenues on completely different samples. So the Census Bureau has a sample for retail trade. The BLS, through an entirely separate process, goes out and samples goods. Then they're aggregated up to fairly high levels of aggregation, and then the BEA combines them. Okay, but the prices and quantities are basically from entirely different data frames, from different establishments, and so on. So it's not surprising we're not going to have great measures of inflation and therefore productivity. It's also collected through a complicated system, which is built up over the years. I hasten to add it's an excellent system, but again, it's built on 20th century information technology and 20th century techniques, and it has some inadequacies. One, it creates a tremendous burden both on the agencies for traditional data collection, but also on the firms. And I'll talk more about that in a second. And what I want to focus on, the interesting economics today, is it's very hard to account for product turnover and quality change in this system because they just don't have the data to do it right. But that's what we want to fix. So what is this? What's the re-engineering? What's the re-engineering? So on the bottom left, I imagine they're data warehouses. Firms have basically, every time you buy something at a store, there goes beep, or every time you buy something online, there's a line on your statement, and that's going to give at the scanner or barcode or product level both the price and how much you bought. And those data are already setting in the information system. And our not very ambitious aim is to basically rebuild GDP statistics and inflation statistics using those. But you literally have a fire hose of data. And the question is, how do you get it from the firms to the agencies to turn it into things that we can use as economists and policymakers of GDP and inflation and allied measures? And how do you get improvements in quality in ways I'll talk about in a second. So how are we going to do this? We are going to do what we call this reset project. We were told by the Sloan Foundation we needed an acronym, and this is what we came up with, or I should say my colleague Charlie Brown, who's the king of acronyms. Re-engineering economic statistics using economic transactions. And the re-engineering is quite intentional. As you'll see, this is a partnership between economists and computer scientists in a way to basically think about as information technologists. And we want to build up measures of consumer inflation and components of GDP from these item level transactions data. And that requires changing the infrastructure for data collection and processing. So basically, that's the re-engineering part. The agencies are going to have to handle information the way firms do, rather than the way survey organizations do. And this is coming from a former director of the Survey Research Center. We just have to do things differently. So why might we want to do this? So first slide is for the benefits for basically this audience, the professional economists, the policymakers, the researchers. So we're going to get better data. I mean, Jay Powell, it's going to be an FOMC announcement in I guess 12 hours. And we would like them to have better data, and they would like to have better data. They would also like to have more timely, and they would like to get rid of these revisions that I've already talked to that. There's also infinite appetite for more granular data, particularly geographical level. We would love to have, not we, but the Congress wants GDP at the congressional district level. Every alderman wants it at the ward level, and so on. And that's actually important. I mean, if you're trying to figure out where to put the next store or the next data center, actually knowing where economic activity is located, where labor is located on a granular level might be really useful. But there's also an appetite for more and more detail. And what I'm going to talk about today, although I'll return to this issue of interpolation, extrapolation at the end, is how you can do improved inflation measurement if you actually have these kind of data. And they're basically two things we're going to do. First, we're going to handle substitution effects. So I'd have to remind you of Econ 101, Laspaire's index, Posh indexes, substitution bias. But basically, the notion consumers adopt to changing prices. Relative prices change, and the cost of living can be minimized by shopping around and switching goods when there's relative price changes. To capture that in a price index, we know how to do this for decades, but we haven't had the data. Because not surprisingly, if you want to capture substitution effects, you need price and quantity measured simultaneously and consistently. And that just hasn't been possible at the granular level in the official statistics. And I'll show you that's really important in the food sector. And then the second issue is how you deal with ubiquitous quality change. And here's where the machine learning part will come in. We're going to use, when we wrote the paper, we call it machine learning. Now I've got to call it AI because that's the buzzword, but we're basically going to train models to handle product turnover and try to convince the statistical agencies that they should do this too. There's a second slide here, which is what are the benefits to firms? And this is a very important slide because we're asking for at least a look at crown jewels, which is their information. And they need to be convinced that there's a good reason to do it. And believe me, I've had a lot of conversation with business executives saying it's better data. Jay Powell needs to know the inflation rate in more accurately. They say, yeah, except I'm a profit maximizing company and information is my stock and trade. Why should I turn it over to the government? It sounds like a big bother too. So that gets you in the door, the public good. But there's an important private good. There's a serious problem when there's a disconnect between what the agencies are reporting and what the firms can tell. I mean, they have data that's kind of the GDP and the CPI for their firm. And if their data are going up and the official statistics are going down or vice versa, that's a real problem. It could be it's a problem in the data, or it could be that the firm is either under or overperforming in price or quantity the market, and that's a serious problem for them, and that gets their attention. And in doing this project, we have developed lots of examples of this. There's also a possibility to reduce respondent burden, and here I'm talking about the firm respondents. So firms in the U.S., a big firm will get 30, 40 surveys a month from various statistical agencies. They are often redundant, overlapping, annoying, because they're asking questions that the statisticians and economists want to know the answer of and might not be readily answerable from the information systems of firms. So the idea is that the agencies need to start taking the data as they are and then turn what I've called the naturally occurring price and quantity data into things we're interested in, like GDP inventories and inflation. So there would be substantial setup costs, but there could be reduced burden. Collecting of price data is particularly burdensome on businesses because I'm going to describe how the BLS handles product turnover and actually requires conversations between BLS pricing agents and store managers, which are burdensome. And the kind of aggregator who's a partner with us in the demonstration project can be helpful. They already collect the data from the firms, and possibly they could just turn it over to the government, probably for a substantial fee, but it might be cheaper than collecting it. So this is not optional. So I've been wanting to do this for better part of 2.5 decades. Everyone in this room wants better data, but the world is catching up, and the 20th century is about 25 years beyond us, and the old-fashioned modalities just are not going to work. The Advanced Retail Trade Survey, which is the backbone of personal consumption expenditures, this is the Census Bureau survey, which I mentioned, has a response rate of only 2/3. It's a non-mandatory survey. Firms go in and out. If a big firm goes out just because they didn't report that month, that's if the Census Bureau didn't fix it, that could be the Great Recession. So it's a huge problem. BLS is being respectfully asked to bow out of stores. So some chains are saying, please don't bother our sales clerks or managers. Here's the data tape. Dates me, but but here are data. You deal with it, but they aren't doing it systematically. And when the BLS gets the price quotations from scanner data, they throw away the quantities. and the Census Bureau we obviously want to use them simultaneously. So the notion is go out and get the data systematically, simultaneously, and replace these first two steps. I'm going to be talking about goods, and this is the easiest place to start because they're the most scanned goods already. But these techniques could be applied to a broad range of goods and services, including a lot of services like airlines, hotels, utilities, rents, which are also recorded electronically. The RESET project is working with a bunch of modalities for data collection. I'm going to talk about our partnership with Circana, so I'll skip over that. We also use Nielsen data, including from the University of Chicago, but also directly from Nielsen through the Census Bureau. And then we're actually working behind the firewall of at least one big retailer, whose I can't disclose because of an NDA. We're agnostic whether the agencies should build their own APIs to suck in this data or use third parties. We're experimenting with both techniques. So this is the point in this talk where I say, be careful what you ask for because you might get it. So I'm now have access to a data set which is essentially a census of store level transactions for 2/3 of consumer goods. So it's very big. And you're confronted with a fact when you're looking at item level data. So think of doing inflation as a panel data problem because you want to follow the same basket over time, but the basket does not cooperate. There's huge attrition, makes the labor force seem stable. Anyone who has tried to buy the same tennis shoes a year later knows that at the very granular item level, it's very hard to follow a good. And let me give you an example. So on the left is the Air Jordan Model 36 men's basketball shoe. And it has a price, which is what I'm interested in, and then it has a style number which corresponds to the barcode. Okay, and some BLS enumerator, after there's a very complicated probabilistic process that might have picked this Air Jordan shoe to price. And his or her job is to follow that shoe for 4 years, going back actually to the same store. Okay, but what's going to happen 6 months later? The Air Jordan 36 is going to be gone, and you've got the Air Jordan 37. Now, to my unexpert basketball shoe eyes, they look pretty similar. To the computer, they'll look totally different. That style number is totally different. That means it's got a different barcode. So if you're doing this automatically, it might be apples and oranges as far as the computer is concerned. We're eyeballing it. It looks pretty much the same. But the other important thing, and this is what, of course, we nerdy economists care about, is the third line. The price has changed. And not surprisingly, often when items change like this, that's an occasion for price change. So the question, and one which has to be answered literally millions of times a month if you're going to use these kind of data, is that $10 increase in this shoe inflation or quality change? And how might you do that? And that's where the AI is going to come in, because we're going to actually want to do that with the help of computers, because we couldn't possibly do it ourselves. There's really interesting economics here related to product turnover and prices. So the first thing to note that this turnover, the turnover of products is ubiquitous and fast. So memory cards, coffee makers, these are just goods we happen to have good data on. The annualized turnover rate, both entry and exit, is about a quarter for memory cards. When you get down to apparel, it's even higher. And the half-life of a TV is about three months. Not that you can't buy the same Sony Trinitron, at least to our taste, but it's going to have a different model number. And often when there's a change in the inputs, because they're sourcing the LCD from a different source, it'll get a new SKU. So you got to deal with this. So what's the interesting economics? This is a chart for memory cards. This is the life cycle of a memory card. So what I mean by a memory card is a representative memory card labeled by SKU or product code. Okay. And time zero is the entry of the memory card, and the blue line is the sales. And this is on the log scale. This is not, it's not percent. After 3 quarters, there's been a 2 log point change in the share of this memory card, okay? And then it dies off, okay? What's happening? It takes some time for the new model of memory card, maybe it's a little faster, maybe it's got a little more memory to catch on. And then after about a year, some other new memory card comes along and it's better, and this older one's gonna lose sales endogenously. And not surprisingly, there's price dynamics underlying that. So the red line, which is on the same scale, so it looks small, but that's actually a 40–50% price drop and this is very, very standard. As the product matures and competition from newer, better models comes in, the price tends to fall. If this were apparel, it would have fallen 90%. Okay, so you're going to need price indices that will handle this and this very endogenous and sort of crux of the matter product life cycle that's related to technological improvement in the thing which is driving out this memory card. So how would the BLS do this? Going back to the Air Jordan example, the BLS would send this poor enumerator to the store, and they would be confronted with the memory of the old shoe and the new shoe, and they would have to decide. And they're basically 2 polar cases. Option 1 is they look at it and say, they squint, and they might call up the shoe expert in Washington, and they'll say, oh, it's basically the same. They just changed the color or the trim. It's functionally the same. And in that case, the $10 should be counted as inflation. There's a polar case. They say, no, it's gotten thicker soles and it's a little higher, and Michael Jordan isn't as popular or whatever. It's not comparable. And in that case, they just take the percent change of the old model, connect it to the percent change of the new model, and that difference, in that level $10 difference, is technically linked out, which has the implication that they're implicitly assuming it's a quality change. Okay, those are the 2 polar cases, and that's how about 90% of product turnovers are handled in the CPI. For about less than 10%, mainly tech goods and apparel, they do some kind of hedonic adjustment. It's on a case-by-case basis. And when they get new items after 4 years, they always link out the product change. So basically, all of this dynamism that you saw represented in that picture is basically not ignored, because they try to handle it, but it's handled very imperfectly because it has to be basically handled by hand. So that's not feasible. We cannot, we couldn't possibly have someone stare at every new product in our data file with 1 million goods and do this on a case-by-case basis. So what we're going to do is hedonics. So the idea is you can think of entry and exit as a missing data problem. Okay, so if I want to compute the inflation rate for something which has disappeared, I can't do it because I have the base price, but I don't have the current price. So what I do is estimate an attribute-based model of the prices and ask what the thing would have sold for given its attributes and what those attributes are selling for in the marketplace. You have to update this period by period, and that will be a virtual price change for an exiting good. For entering goods, it's the same thing. It didn't exist. It didn't exist last period, so you actually have to go backwards and ask what would it have sold for had it had that bundle of attributes and been available. So basically, instead of just doing the continuing goods, is essentially what's done in the CPI, you're going to do imputation of entering and exiting goods, and over any period of time, this is most goods because product turnover is so ubiquitous. And to do that, we're going to use a machine learning model. So to do this, although we're gearing up to do this on more data, we've done this actually for the KILTS data for food at home. So for 10 years of data from the KILTS Center, we have item level data for basically all grocery stores. And this KILTS basically captures every month about 50% of all retail transactions in grocery stores. So it's a very, very big data set. We aggregated up to the national level. This is, it's going to be a tricky issue because the KILTS data set does not have detailed descriptions of the products. So let me tell you what we're going to have to do hedonics on. Let me show you the kind of data I said the statistical agencies have to take the data as they come. Well, let me show you how they come. So this is what a product attribute looks like in the KILTS data set. So the top two lines are soft drinks. The black is is just the data. They have brand. We actually have the name of the brand, but you're not supposed to reveal brand, so I put that in quotation marks. And then it has a bunch of marketing shorthand. And you stare at it long enough, you can actually figure it out. So DT and in the first line stands for diet. R stands for regular. 12P stands for 12-pack. Okay, so those are the attributes. But believe me, this is not a nice column vector of data in a data file that you could hand to an RA. So we're going to train basically a customized a large language or medium-sized language model to actually encode these and then do hedonics. Each good has a kind of a different lexicon. So toilet paper is the next example. Again, you have brand. Notice that 1P means one ply for toilet paper, but P means pack for soft drinks. Since they use the P for ply in toilet paper, they use PK for packs in that. So even across goods, you need a different sort of dictionary. Now, this is exactly the kind of thing computers and machine learning are good at. You have data which a human could process, that we could hire some beleaguered RA to spend their summer or their lifetime in figuring out these data. It would take infinite time. They wouldn't be very good at it, but these are eventually human recognizable. And this is precisely what machine learning, aka large language models, are meant to do. Recognize patterns really efficiently. So this is a very good application for standardized machine learning techniques, and that is what we did. So we have an algorithm that basically does natural language processing on those marketing text strings. What that basically does is it turns them into some sine waves that basically you can do principal components on if you want to translate what machine learning is into econometric speak. Then we basically take off-the-shelf hedonic techniques from regression I don't have time to go into the details, but we use the Erickson and Pecos approach, which basically does two things. First, it predicts the percent change in prices, not the level of prices. And secondly, it updates. You have to re-estimate the coefficients each period because even if you have fixed attributes, their value might be changing. And the third thing is it's a two-step procedure where you first fit the equation in levels. You take the residual from the level equation, stick it into the second stage percent change equation, and that captures residual variation, things you did not encode. Okay, we do the standard machine learning. We have big data, so we divide the sample into a holdout sample and a fitting sample and a test sample, and we run with predictions. And this is what the schematic is. The bottom two levels are basically the reading the text. We're updating this with a so-called transformer algorithm. The orange levels are the neural net, which is think of that as a nonlinear regression on the text data, and then the top layer just does a price growth prediction. Actually, I can show. I was going to cut this out, but I have a more academic audience. This actually works. Okay, I want to pause on that because you might not have, because I mean you've seen the kind of inputs, and if we can't do the price predictions based on that kind of inputs, this is not going to be a non-starter for implementing this at scale. And look at the the right-hand side. This is a distribution of goodness of fit for food and non-food. That's the blue and red line. In sample is solid, out of sample is dashed. And this is for the growth rate of prices based on attributes like this. So for the median let me help you out. The median, for the median good, which is here, we basically have a near accuracy, sort of an R squared like of 50%, and this is for a change in price, which we think is pretty good. So you can actually do this. Here are some goodness of fits by various types of goods. So baby food, we can be spot on because you have pretty good descriptions. Left off the table are goods like ice, where you can't really predict the hedonic model of ice because it's got like it says 5 pounds and it never changes. So for some goods, you're not going to be able to do this for, but not surprisingly. Okay, does this work? So let me show you. Oh, before I do that, I got to remind you of Econ 101. So I'm going to show you 3 price indices, quality adjusted and MASH model. So the first is going to be the traditional Laspers index, which is what's used for the CPI. And basically the idea there is it uses lagged weights. So a price index is the weighted average of price changes. The weights are lagged in a Laspers index. Why is the BLS didn't do that because they thought it was the right idea? It was because they only had the quantity weights with a lag. So it's just totally instrumental. And that we well know, we've all taught it, that's going to understate real growth, overstate inflation, because it doesn't account for substitution effects. Relative price changes don't change the cost of living because the weights are fixed. The Posh index, which is isn't feasible except with data like this because it requires current expenditure weights, is the opposite. You use current weights, and that's going to overstate adjustment and therefore understate inflation. The superlative index is basically a weighted average of these, and Irwin Dewart proved in the 70s that the right weighted average and having the shares change over time is going to give you a second order approximation of the cost of living. Okay, and then to do that, and this is kind of pedestrian, but wasn't really possible until you had this kind of data, we're going to do these superlative indexes at the item level and consistently aggregate up. And this is really important because a lot of the substitution that goes on is not between chicken and fish, which is how we teach it. It's between Folgers and Maxwell House, or a 10 ounce and a 12 ounce pack of Folgers. And that's actually where a lot of the action is, and that can only be picked up in these kind of data. And then we will do hedonic versions of this by imputing virtual prices for the entering and exiting goods. So here is for the KILTS data, which Niels University graciously licenses to us. Thank you. The top line, the blue line, is the CPI equivalent, and this is old data from 2006 to 2015, and it showed about 1.5% inflation per year. Okay, the bottom, the thing with the third arrow, the animations aren't working here, but is the Posh. That's the red one. It shows deflation. It's not an accident that we teach substitution effects with the food example. There are huge relative price changes, and you actually get, if you use the Posh index and the Laspers, you would have deflation rather than inflation over this period. Now the Tornquist is the green line in the middle, which is the appropriate weighted average, and it's showing about half the inflation. So getting these substitution effects right is just huge, okay? And it's particularly important in food. The interesting thing is we find unmeasured quality change in food and grocery stores. So for each of these, we do a quality adjusted, and the quality adjustment is roughly the same on each. So doing the hedonics takes about 1/4 percentage point inflation off of each of these indexes. That's per year, not cumulatively. So there's pause on that. There's 25 basis points in grocery store of unmeasured quality change. This is like low-tech good. This is lettuce, okay? And well, things like baby food and so on. So this is, so if we look at tech goods, and we have papers on this, the typical unmeasured inflation is probably more like 50 or 60 basis points. So this is really big empirically, and it has big implications for productivity measurement and for inflation. Let me actually, in the interest of time, I'm going to skip over this because I want to talk about the demonstration project. So what have we learned? You can do this, and you need to do this. It's feasible to inhale data like this, and most importantly, it's feasible to deal with the product turnover using these hedonic techniques. Okay, and the implications are important. I've already mentioned this. So I want to tell you where we're headed with this in my last 5 minutes, and then I think I'll be roughly on time. So what's the reset agenda for official statistic is the agencies can and should do this, okay? But they're not going to do this unless we actually show them that it's feasible, and they're not going to be convinced by using decade-old KILTS data. So we just got funded what we're calling the Reset Demonstration Project, and it's going to collaborate between the team I've already introduced and Circana, which is formed out of the merger of NPD and IRI. It's a big aggregator. It and Nielsen are basically the market leaders. They cover overlapping but complementary goods. In particular, Circana has data on they have food at home because they bought that when they got IRI, but they have consumer packaged goods and general merchandise. It's basically 2/3 of consumer goods. It's basically all of consumer goods except autos, gasoline, and furniture. So in addition to food, it's health and beauty, which is big, things you buy in drugstores, apparel, electronics, and tech goods. So it's about 66% of consumption of goods in the CPI. 40% of the CPI is goods. 2/3 of the economy is goods. So we're getting 8-10% of GDP. Okay, and we are going. We have access to these data, essentially a universe of transactions in real time. We're going to set up a mini statistical agency. John Haltwanger, the folks at Circana, and I and our RAs are going to do this. And we're going to put out monthly releases. We're going to have them look like the PCE or CPI release, except it's going to be one release. You're not going to have to go to one agency for the price and another agency for the quantity. We'll be able to do these superlative indices with some engineering. We will then do the hedonics and do the product turnover. And we're going to release 2 types of series. Type 1 is basically series which replicate the methodology of the PCE or CPI price indices, because you're going to have to sell this. You're going to have to show that you can basically track what's known, and maybe the data will be somewhat different, but we want to separate out differences in data from differences in formula. Plus, you're going to have to, we're quite serious. We think the agencies should switch to this. So you're going to need to run parallel formulas for a while. So we're doing that. But then the second thing is we're going to put out these new and improved measures, ones that do substitution effects from the item level up, and secondly, basically do hedonics at scale. So we have an ambitious timeline for this. We have data going back to 2020. We hope to get the food index out by the end of this year. We hope to have price and quantity indexes for the Circana index sometime next year, and then by the end of next year or the beginning of the following year, we hope to actually do this at scale with all the hedonics. So that's, I don't have this yet. We just got the funding. We are writing the contracts, but we believe this is feasible. And the idea is basically to hand an infrastructure to the agencies and say, if we can do it, you can do it, and you really need to do it. So that's where I am. Thank you.
Okay. Thank you very much for this very, very interesting presentation. Now the discussant is Professor Ueno from Hitotsubashi University.
Okay, thank you very much. My name is Yuko Ueno from Hitotsubashi University. And first of all, I'd like to thank Professor Shapiro for this very exciting and insightful presentation. I actually learned a lot. And I'd like to focus my comments on mainly on research project, but let me quickly start with my own experience. Okay, so that is about this issue of revision. And this is actually, really a big issue, not only for the practitioners, they are working at the NSOs, but also the users. Okay, and in fact, I myself had been working at the government and just after the COVID-19 shock recession, and I was in charge of the estimating a GDP gap. And so you see from this figure, Japanese economy had been experiencing the negative GDP gap for a while. And in the meantime, a lot of politicians, as well as the people in the government, they were discussing the size of the necessary supplementary budget to stimulate the economy. And sometimes they would have liked to make a reference to the estimated size of GDP gap to have an idea of the size of the supplementary budget. However, I myself was a bit concerned about it because since this is just the estimation, so it's really up to the methodology. But plus, I also recognize well that the estimated results could be vulnerable for the future revisions of the various statistics used in this estimation. So anyways, this is just the introductory part. And now let me move on to my remarks on your research project. So the first point is a difficulty in the adjustment of quality change. So as Professor Shapiro pointed out, I really agree with the view that it's really important for the NSOs to deal with the price change caused by the quality change, particularly if the items are experiencing a quite rapid turnover. However, I recognize that at present, several NSOs have actually partially introduced heading models. And in case of the Japanese CPI, the NSO is using a heading model for only 4 models, so that the extent of which is really limited. And so that means the heading model has not been used as a sole basis to construct CPI. And in my understanding, these models are equipped with the very good practical advantages, but how about their robustness? So that is my question. And the quality adjusted price indexes based on heading models can behave quite differently depending on the set of the variables included in the model. So I'll come back to this point later. And it's hard to evaluate which variables should be or should not be included in the model. And since this heading model is not, usually it's not combined with the theoretical background, and so that sometimes it might be a bit difficult for the practitioners to defend their model specification because of the lack of theoretical, theoretical background. And the third point is time series stability. So maybe the revision issues might be critical under this methodology. And fourth, multicollinearity among the variables included in the model, omitted variable biases, as well as interactions between characteristics included in the model. This has been pointed out and has been discussed a long time with regard to model specification. And in this regard, I myself consider that your project to apply the machine learning on heading residuals could be a quite innovative proposal in this regard. And plus, I think there are additional advantages of applying machine learning on heading residuals, like the estimation results are derived with quite high precision. Plus, normally it shows good fit, particularly in non-linear cases. But here, I like to point out a couple of possible concerns, mostly from practical aspect. One is accountability. So I think NSOs should be accountable for the statistics they publish. They do not need to explain everything, but sometimes they need to, identify the factors behind price movements, at least to a certain extent. But given that, the basic feature of machine learning, it could be a bit like, somewhat like the black box process, and so that it might be a bit hard. And the second, practically, the NSOs also need to take account of clarity, meaning that interpretation of the estimated parameters in the hidden models, they should be, should be understood clearly. But in case of the usage of log linearized values, sometimes it might not be so clear. And second, intuitive validity, meaning that the result or derived price indexes align well with people's perceptions regarding the recent price development. This is also something really important, but it might not be guaranteed as a result. And thirdly, simplicity is quite essential for the NSOs as well, meaning that feasibility for monthly and timely publication is secured. Okay. And the last point is robustness of the results of cross-validation and overfitting issues. This is somewhat technical, so I'm going to skip it. And now I'd like to come back to the point of the stability of the estimation result of the hidden models. So you might quite well have already known about this, but let me show you one small example. This is the price quality adjusted price indexes. Okay, derived from hidden models I myself prepared. And this is a development of the price of the residential land with house. It's transacted in a small municipality located in the western part of Tokyo Prefecture. Actually, this small municipality is where my university locates. And so I estimate, so the estimation equation is shown up above. This is somewhat quite simple, but something like the bit standard. So by using the estimated parameters delta t, these are the parameters of the time dummies denoted as large t for price I transacted in period tau, with controls of a bunch of the characteristics of the land denoted as large xi, and the number of the characteristics included in the model is denoted as capital K. So here, in case of model 1, described in the blue line, okay, I try to limit the number of controls or characteristics in the model, and then I increased the number of the other characteristics, okay, with regard to model 2 that is shown in the orange line. So in fact, I expected the derived price index of model 2 should be more stable compared to the model 1, but unfortunately it was not the case. And you could see that there are a non-negligible extent of discrepancy between these two price indexes. So for me, it's a bit difficult to decide or discern which one is better with regard to the price index for the residential land. And the next point is the issue of substitution. So as has been highlighted by Professor Shapiro, I completely agree with your view that substitution effects, okay, this is really important and should be reflected, okay, by using superlative indexes. And in my understanding, theoretically, expenditure weights that would be used for to construct superlative indexes need to be calculated at the levels closest to the consumption behavior, so meaning that the real substitution occurs. So with regard to the grocery case, for example, the researchers, including myself, they consider that this kind of substitution occurs at a very elementary or low level. So for example, junk code level, Japanese article code level of the scanner data should be used in this regard. However, practically, if we derive expenditure weights by using junk code, I think it can be very volatile or even zero. And so that would lead to the unstable indexes. So in this regard, I think the NSOs need to take some balance between theoretical accuracy and statistical stability. So that is my second question. And another thing I like to note is the quality of the scanner data. And I understand that in your country, the quality of scanner data is not bad. And so that it normally includes quite a lot of rich information with regard to the item's characteristics. But that are not always the case in my understanding. So I've heard from some people from the other countries' NSOs that their country's scanner data's quality is not so good, and so that it cannot be directly applied for the hedonic models. Okay. So finally, so I come back to the question like which price indexes, okay, have been adopted in practice and the reason why they have made this selection. And so I looked through the manuals of the CPI or in other manuals issued by Eurostat, etc., and tried to find out what people are currently doing and whether if there are any rooms for them to further improve their qualities. And I actually was not able to find out the exact reason why they are choosing, each of the price index. But I got an impression like the second price index, for example, called Gex-Stromquist. This has been used by the several NSOs. And I assume that the reason might be because it can be constructed as Collie. Okay, but anyways, it has got the disadvantages, like it cannot deal with the effective price increases through new products, and so that there are always like the trade-off between some advantages and disadvantages. So finally, this is my last slide. So although it might be a bit difficult to identify the best solution to construct price index, but at least I think that NSOs need to make ongoing efforts to explore the possibility to use scanner data, web scraping, and possibly administrative data, as well as hidden models. And also, I think that it would be beneficial for them to pursue cooperative relationship with international partners by exchanging views or sharing experiences. So in this regard, I actually would have liked to ask the practitioner audience, okay, are they here for further inputs to share their own experiences? But by looking at the audience, I cannot find any from the Japanese NSOs. But anyways, last but not least, I appreciate Professor Shapiro for your further suggestions for the Japanese NSOs to improve the qualities of their statistics. Thank you very much.
Thank you very much.
Oh, I don't want to, thanks for those great comments. And you put on the table key issues, and I want to highlight it. I really can't respond to it, but this issue of transparency and having people understand what's being done is really important, and agencies will have work to do that. The actual statistics aren't that. I mean, we're replacing one black box with another. I mean, hedonic adjustment and machine learning is fancy, and it's definitely a black box. My computer science collaborators just tell me, don't try to figure out what's happening. We know no one knows, but it works. But we have to show it works, and if we have diagrams like you were showing with the time-Dunning approach, that's going to be a problem. So what they have to do. We would have to convince people this is important, but it's also a black box that having thousands of judgments by BLS enumerators, basically using seat of the pants or expert knowledge. That's a different kind of black box. It's one we're so used to we don't think about it, but it has some of the same features. I just one other comment on your first point about left out variables. That I went over it quickly, but that a nice feature of the Erickson-Pecos procedure is that it is somewhat robust to that, because again, you take the residual from the first stage and treat that as a regressor in the second stage. And if you've left something out, that's going to go in the residual, and it works quite well for left out factors. And in fact, we kicked the tires on this. We left out brand and left it in the residual, and actually the Erickson-Pecos procedure worked well. But the point you raise is really important, and that and partially one way we respond to it is using this Erickson-Pecos procedure. So I'll stop there in the interest of getting questions from the audience, but you hit on all the key issues, and I thank you.
Thank you very much. We have about 30 minutes, so we want to collect as many questions as possible.
This is super exciting. So I have two very in the weeds questions that you can decide, you can just tell me later, but put them up there. So with food, we know that temporary discounts are a huge thing. So I just wondered how you thought about that. And one of the things that I learned at one point from the way the BLS does stuff is they try to be practical. So when they do airline pricing, they deviate from what they do throughout most of the rest of the CPI, because they realize some people are willing to fly at 3 a.m. To get the absolute cheapest price. So when they're trying to figure out how much does it cost to fly from Chicago to New York, they take a weighted average of the flight that's at 2 p.m. that they're supposed to be checking everything, and then the cheapest thing. So what are you guys going to do when you replace all this? Are you going to keep things like that where they've invented some clever workaround to reflect reality, or are you just going to override it with the way your procedure works?
On the sales, those are in principle in the data, and they should be. I mean, if you're buying things on sale, that's cheaper. And the nice feature of these approaches is you're tracking how much is sold at the item level. So if it's a sale and not much is sold, it's not going to really show up. So I think it's being handled correctly. It's the kind of thing you want to kick the tires on. Same with the airlines. That's, again, having the price and quantity is off together is often the answer to this, because if that low price 3 a.m. inconvenient time isn't going to get much weight if not many people choose to buy that. So again, that's going to be handled in principle correctly, assuming you actually have the granular measurement. And I think airlines, I think, would be actually relatively easy, because there are great data as kind of a legacy of the Civil Aeronautics Board allows you to get that. So.
Okay, next.
David Weinstein, Columbia and NBER. So I think this is really interesting, and I like the basic approach. I think it's I think it can make a lot of progress. I guess I worry a lot about the implementation, and when I think about the implementation, I think about 4 types of problems. The first is a timing problem. Like, suppose that the government actually goes in and does this, okay? There's going to be an enormous incentive for companies to buy the same data and beat the government on the forecasts. So it seems like I'm not quite sure how we would handle that. But the second thing, I think the second problem is manipulation. And there, again, imagine you're getting data from Amazon or something like that. Amazon can directly control the timing of its sales to manipulate what prices are going into the index, and that would then create certainly a very big incentive to the extent that there's inflation-adjusted bonds, or other things. That creates a big incentive for them to try to manipulate the price indexes that the government's using, or even and then kind of a third issue is fraud, right? You've got a Fed meeting coming up, and suddenly you want whatever interest rates to go up or interest rates to go down, and you misreport, or you actually implement the changes. And so, I think you got to figure that people are going to use the same algorithms and try to beat you in terms of the speed. And I just don't know how you'd handle that. And then I guess the fourth issue that I think is out there, so timing, manipulation, fraud, and is monopoly power, right? At the point that you're using big data providers, right, there's potential there that they could withhold the data. For or say oh, it's really expensive, we have to raise prices, and how you do that negotiation, I can imagine would be difficult. You can kind of, I understand you can try to get laws to say, well, the government has to monitor all prices of all digital platforms, but my guess is there's going to be a lot of pushback from the private sector if you actually tried to do that. So that's kind of, I think 5 stars on the method, but I'm just worried about the actual political economy of this.
Yeah, those are all great points, and I want to point out that David's done pioneering work on the index numbers, very much related to this. Some of these things I'm more or less worried about. I mean, the front running is a real problem, and you would, if you're working with an aggregator, you're going to have to have a contractual agreement not to do that. I'm not so much worried about the companies manipulating their prices, because to do that, remember, we're trying to get a census of the price, so they'd have to actually change all their prices in order to do this. And if you're really worried about that, these companies aren't going to get more or less weight in the CPI than they have now. So you could imagine them the same thing could. I think that the middle points, I think, are apply equally to how the data are collected. I think the first and the last one are problems, because they're both related with having very concentrated actors, not so much in the pricing, but in the collection. That has to be dealt with. We've obviously thought about this. I mean, the government faces this all this time. I hate to cite the Defense Department as a precedent, but I mean, this is the same problem that you contract with one company for your strategic bombers. So it's a pretty standard government procurement problem when you have kind of scale economies, and it would have to be solved. I mean, in the Netherlands, they've solved this just by passing a law saying the companies have to turn over the data. That's not going to happen here. So there's going to have to be a market and a cooperative solution with it. Yeah, I mean, this is the kind of thing Doge should be suggesting if they're really interested in having government reform driven by IT. So yes, if you have friends in Doge, tell them this. And this is the I mean, there's a hint in the president's budget has talks about consolidating the statistical agencies, the economic statistical agencies, which is logically related to what we're proposing. I mean, we're agnostic as to how the agencies should be organized, but they shouldn't be acquiring the same data twice, once for price and once for quantities.
Jiro Yoshida from Penn State and University of Tokyo. So ideally, I think statistical agency collecting all granular data about quantity and price would be ideal, but probably that's prohibitively costly. Then at the same time, there are many independent price indexes in the market. Like, for example, I myself have been publishing housing rent index for the US for the past 25 years. There are several similar indexes in the US. And then there are private initiatives like Trueflation and other companies producing different indexes for different coverage, different products, and so on. So what do you think of the idea of aggregating those existing independent dispersed price indexes to infer the more aggregate inflation index instead of collecting data from scratch?
Yeah, I think those kind of approaches are the sort of practical things agencies do. For example, the BLS is now using Gas Buddy to collect gas prices. Some of these indices will get you good measures of prices, but not do what we call the full reset, because you're not going to have the quantities. So it's a lot easier to sort of imaginatively collect prices, say by web scraping or other devices, but you're not going to be able to do the superlative indices without actually getting behind the firewall of the firms. So part of the reason, this is also related to David's remark, part of the reason we're also talking with companies is we might not want to rely on the aggregators because of the market power, or but the firms are not, we do not conceive that the firms would ever turn over their whole data warehouse. That's not feasible and just not going to happen for a whole bunch of reasons. But an alternative is basically giving, instead of sending a survey enumerator to count their prices, send them an API where they suck out data from their warehouse that is much more aggregated. It'll be small enough for the government to use it, much less sensitive in terms of business purposes, not subject to the kind of manipulation that David is justifiably worrying about. So I think exactly how this will work is an open question, and we're trying various modalities. The one where we can make a lot of progress over the next year or two relies on an aggregator. But that might not be the way that the data should be fed to the government ultimately.
Maybe the last question from the woman over there.
Thank you. Naomi Feldman from Hebrew University. So this is really interesting, and one of the things I wasn't totally clear on that you got a little bit towards at the end is the coverage. So this could be really good for tradable goods, but for non-tradables, which are a very important part of PCE, it's unclear to me how this method could be used for, housing or for medical services and things like that. And so that's a very important component of inflation for the Fed and for others. And the other question I have really is sort of thinking more deeply about this is sort of, do we think of this more as the truth? So the Fed isn't really in the business of forecasting inflation. They're in the business of forecasting what they think the BEA is going to say what inflation is. And so do we think that the BEA, in terms of PCE, or if we think about CPI, do we think those are going to eventually converge to your measure, or is this just going to be yet another measure? And so it's really going to be a little bit more unclear what is the true inflation rate in the society. So
thanks, Naomi. So let me take the second question first. So the official statistics are just constructs, and they're trying to measure some underlying thing. We're going to have a different measurement of the same underlying thing. At some point, we hope that BLS, BEA, and census will start collecting data this way, and yes, eventually, what the Fed focuses on will be data collected this way, and for reasons that I won't go over again. I think we have to move in this direction. So yes, but we're estimating something where we're trying to, the first set of statistics are basically trying to mimic not the ground truth, but it is the ground truth what the BLS says, but the second is to actually get a better measure of inflation, and I think that would be widely accepted if it addresses all the transparency, replicability questions, which are why we need statistical agencies. And remind me of this first question. Oh, okay. So from the perspective of what we're doing, the distinction is more sort of goods versus services, at least. So services are actually widely covered by these kind of scanner data. So for housing, I mean, Zillow basically built an industry based on collecting administrative data on prices and then basically doing hedonic models based on the limited set of attributes that are parked in counties' tax registers. So actually that's an example. And health, fortunately in the US, because of third-party payment, there's a huge amount of scanner data on health, and the BEA is also already using these for health satellite accounts. So health is another one where in the US at least, because everything is encoded to these multi-digit diagnostic codes, it would be easy is the wrong term, but conceptually easy to do this kind of index for health, and David Cutler is going to talk about some of that tomorrow. So I think not everything can be covered this way, and things which are kind of intangible, which is sort of riffing on your tradable versus are harder. So how to price banking services this way is going to be tough, but that's not because of the data. It's because pricing banking services is tough, regardless of how you collect the data, because it's complicated how pre-checking is paid for. So there are measurement problems, but often they exist whether or not it's sort of orthogonal to whether you collect the data from scanners or survey or some other purpose. But yes, I think this is not a panacea. Because the world's complicated, but as you run through more and more goods, and especially as things get more and more computerized in terms of transactions, I think for services you'll be able to do the same kind of procedures. Thank you.
Thank you very much. It's time to about time to close the session. Thank you very much for very good contribution. So let's give the presenter and the discussant a big round of applause. Thank you very much.